Hey there, Unreal fans! If you ever dabbled in Unreal Engine's material editor, you know it's like this amazing visual playground. You drag nodes, connect wires, and boom, your 3D model gets textures, colors, and effects that look incredible. But have you ever stopped and thought, what's really happening behind the scenes? How does this colorful web of nodes turn into the language of your GPU understands and runs blazing fast? Today we are pulling back the curtain to reveal how Unreal Engine translates your material graph into HLSL, or high-level shading language, the code your graphic card speaks to draw those pixels on screen. This knowledge is super valuable whether you are a technical artist wanting to optimize your work, a programmer looking to debug shaders, or just someone curious about how your art becomes code. Let's jump in. The basics: nodes, wires, and code. Think of Material Editor like a visual programming language designed for shaders. Each node you place corresponds to a specific function or operation in HLSL. A node like add or multiply is basically an arithmetic operation, like adding two numbers or multiplying them together. A texture sample node tells the GPU to look up a color from an image, your texture. The wires connecting nodes show the flow of data, and how one node's output becomes another node's input. And when you connect something to the material's main inputs, like base color, roughness, or normal, those become the final outputs your shader writes for each pixel. Your GPU runs the shader code in two main parts. Vertex shader runs once per vertex. It handles transforming the position of the model's points in 3D space, applying any offsets, and preparing data for the pixel stage. Pixel shader runs once per pixel. This is where the real magic happens. Colors, lighting, normals, reflection, everything that makes your surface look detailed and alive. Example 1. Simple color, just red. Let's start with something super simple. Imagine you plug a constant red color directly into the base color input. In HLSL, it turns into this. Here, float 3 means a 3-component vector. Red, green, and blue values. 1, 0, and 0 means full red, 0 green, 0 blue. So your shader just paints everything red. Example 2. Texture sampling. Painting with an image. Next, say you connect a texture sample node to the base color. This grabs color data from a texture file, like a photo or painted pattern. The HLSL looks like this. Text_in is your texture resource. Text_in sampler handles how the texture is read, filtering, wrapping, etc. UV are the texture coordinates, telling the GPU where to look in the image. We need to create only text_in and UV as parameters. Text_in sampler is already defined. So your material graph node calling texture sample becomes a GPU instruction that fetches pixel colors from an image. It's the bridge between your art and rendering. Example 3. Adding a constant, brightness boost. What if you want to brighten the texture a bit? Just add a small constant like 0.1. That plus 0.1 looks simple, but it's cool. HLSL automatically promotes the scalar 0.1 to a vector, adding that brightness equally to red, green, and blue channels. Nodes like add, subtract, multiply, and divide map directly to these operators. Your graph is really just building the math the GPU performs. Example 4. Normal mapping. Making surfaces look real. Now, for something more advanced, normal maps store surface direction data and need to be handled after texture sampling with the function called unpackNormalMap. Check this out. Compared to the instruction above, it is very similar, but if you miss that detail, you get quite the opposite of what you would want. So make sure the texture object is set to normal And after sampling in HLSL, you call the unpackNormalMap function. Example 5. Static switch parameters, optimizing shader code. Now here's a shader secret weapon. Static switch parameters. Say you want to switch between red or blue color based on a Boolean parameter. A static switch compiles like this. Notice the if and else. These are preprocessor directives, meaning the compiler includes only the active branch code and completely removes the other branch. That's way more efficient than a regular if node, which evaluates both sides at runtime, wasting GPU power. Using static switches smartly can dramatically improve your material's performance, making your game run smoother without losing flexibility. Why you should care? Understanding how your material graph becomes HLSL code lets you optimize. Know when to use static switches versus dynamic if nodes for better performance. Debug. When your material throws errors or looks off, you can trace it back to the exact node causing trouble. Create. Write your own custom HLSL nodes with confidence and precision. Analyze. Interpret instruction counts and optimize materials based on real shader complexity. Unreal Engine's material editor is a fantastic tool that hides a lot of complexity. But peeking behind the curtain to see the HLSL your graph generates gives you the power to make smarter, faster, and more stunning materials. Thanks for hanging out with me. Keep experimenting, keep learning. The more you understand the language of shaders, the more your materials will shine.